Hello, everybody. This is Sunday. It's February 12th, and we are about to start Module 6 of our online astronomy course. Module 6 is about actually two subjects. It's about the moon, and it's about a survey of our solar system, a quick survey. We'll look at the planets and the asteroids and everything else in more detail later, but today we're going to take a quick survey of the solar system in this module 6. Now, before I get to that, I want to give you an update. I have been going out trying to see the comet. This is the green comet. It's because it has a slight green glow to it due to its composition. Its name is C/2022 E3 ZTF. And you may have seen pictures of this green comet, hovering over a mountain, or spectacular views of this thing. These are views taken through very large telescopes that can track the comet for a long period of time, and they superimpose it many times on some foreground object like a mountain or something else. So it is not what you're going to see when you go out there. But I wanted to see what I could see, with my naked eye or with a pair of binoculars. So last Tuesday, it was a cold night, but I drove back to Pineview Reservoir, and the moon was just rising, but still the sky was fairly dark. And I pulled over to the side of the road and looked straight up. And I did indeed see the comet. So this is actually what the comet looked like. Now we're looking straight up into the sky, and the comet is right here in the center, right here. Not very impressive, is it? But this is what the comet looks like. You can tell that there's a faint glow around the comet. Now, if I was to have a longer exposure, I could bring out some of the details, but for that, I need a night sky, a dark night sky, because the background light here with the full moon rising in the sky, and it was just too bright for me to see any more detail than that. This is actually through a fairly wide angle lens because I wanted to capture a large part of the sky just to put it all in context. And so there is the comet. So I think that's the only view I'm going to get of it. Yes, the moon is going toward the new moon phase, so the moon is less and less of a problem, but the comet's brightness is declining rapidly. And so I guess I can say technically I've seen the comet, but not exactly an awesome experience. Okay, how about Module 6? Okay, Module 6, as I said, has two subjects, the moon and a survey of the solar system. And in back of me, you see a picture taken on the first moon landing back in July of 1969. And that is one of the astronauts there in the background, Buzz Aldrin. And he is standing beside the lunar module that they landed on. And Neil Armstrong, the first person to step on the moon, is taking the pictures. What they did is that they would step down a ladder from the lunar module and onto the surface of the moon. Then when they were done exploring, they would go up, and only this top part of the lunar module would take off. The bottom stage was left below. The top stage went back and actually rendezvoused with the command module that had Michael Collins in it, and that was circling the moon above them, waiting for them to return. You can see a couple of the experiments. So here is an experiment that's set up on the ground. Here's another one out here. This might be a camera. This might very well be a camera that's out here taking a picture both of the American flag and of the lunar module. The flag is held out by a wire. Otherwise it would just hang limply. There's no wind, no atmosphere on the moon. But we have explored the moon. There have been a number of successful missions where people have walked on the moon. They have done geology. They brought back over 800 pounds of rocks back to Earth. Some of them we have analyzed already, and some of them are kept in sealed tubes, nice and in pristine condition, so that as we go on in time, it's been 50 years, but almost 54 years this year since the moon landing. But we have evolved better techniques. We developed better techniques for studying this soil, and we want to have soil that is in a pure state. And so those tubes have yet to be opened. But how about our moon? You'll be learning all about the moon's history, how it came to be. It's interesting because of the inner planets, namely Mercury, Venus, Earth, and Mars, only Earth has a sizable moon. Mercury has no moon, Venus has no moon. Mars has two moons, but they are simply captured asteroids. And we're the only planet close to the sun that has a large moon. So how did we get this moon in the first place? What we have discovered is that a large Mars-sized object, very early in the Earth's history, when it was just forming, here is Earth, and that Mars-sized object slammed in, boom, and made a glancing blow and kicked material off of Earth. And that material coalesced to form a moon. And we used to think that happened, it took quite a while for that material to solidify and form the moon. But recent calculations have shown that it could have happened very quickly. And you can read about those or see about those in one of the extras that I've included with Module 6. So a lot to learn about the moon. It is amazing that there are many nations, several nations have plans to return to the moon. The United States, of course, and China does. China's already landed a little rover on the moon, not manned, but a little rover that can just wheel around and explore the moon. So I read a prediction the other day that in the next, by the end of the century, the moon is going to be fairly a crowded place. Not a huge population, but there's going to be lunar bases all over the place. And many of them are going to be at the South Pole of the moon because water in the form of ice has been discovered there in craters that never gets lit by the sun. And those would act not only as a source of drinking water, but you can break water molecules, H2O, into hydrogen and oxygen, and those can be used as fuel for rockets. So, really interesting story. You'll learn all about how the moon formed, what the various phases the moon went through, what is the moon like. Here, this that they landed on initially is one of the relatively smooth areas. And there are also some rockier areas. These smooth areas are called seas because they look dark when we see them from Earth. And in fact, this Apollo 11 landed on the Sea of Tranquility. So they're standing here on the Sea of Tranquility. Relatively flat. There are still some boulders and stuff around, but there's also more mountainous terrain. And those are called the highlands. And you'll learn about how the seas called Maria. Maria is a Latin term for seas, so they're actually referred to as Maria, how the Maria were formed, and how the highlands were formed. So I hope you enjoy learning about the moon. And, still, here it is. I remember watching the moon landing, watching every bit of that coverage, watching the first steps happen on the moon, only about a second after they happened, because that's how long it took light to travel to us from the moon. So that's how long it took the recorded image to the video to travel from us here on Earth from the moon. But I remember that so well. And still, 50 something years later, I still go outside and I look up at the moon and I just am amazed that that is where people have actually stepped their foot. The other part of Module 6 has to do with a survey of the solar system. And in that, you'll learn about the major divisions of the solar systems. There are the terrestrial planets. Terrestrial meaning Earth-like. Those are the planets that are near the sun. Those planets are dense and they are rocky. And those are Mercury, Venus, Earth, and Mars. We also have the gas giant planets, the Jovian planets. That means Jovian is like Jupiter. And those are Jupiter, Saturn, Uranus, and Neptune. Those are very large. They're gaseous, and they're not nearly as dense as the interterrestrial planets. So why that difference? And we'll learn how the solar system formed. Where did these 8 planets and the comets and asteroids and meteoroids, where did those all come from? And it happens that about 4.5 billion years ago, roughly, there was a huge cloud of gas and dust. And that gas and dust was slowly rotating, because it's hard to find anything in the universe that isn't rotating at least just a little bit. And then something happened. Maybe a passing star came by, maybe a supernova went off someplace else, but something gave that cloud a little kick. So it started gravitationally collapsing and was pulled inwards by its own gravity. Now, if something is spinning and is pulled inwards, what happens? If you've ever seen an ice skater do a scratch spin, what happens? And if you haven't, there's a video on that in the module. What happens, she starts with her arms stretched out, and she starts her scratch spin, spinning around her own body, and then she pulls her arms in slowly. And what happens? She speeds up. She goes faster and faster and faster. Well, that's what happened to this cloud of gas and dust. It started to spin faster and faster and faster. Now, if you've ever seen somebody really making pizza, I mean, really seriously making pizza, what happens? You get this ball of dough and you toss it into the air and you twist it as it goes up. And as you twist it as it goes up, that ball of dough starts to spin and spin. And what happens? It flattens out into a disc. And that disc is all rotating around the center part of the pizza. Or in this case, all of the planets are rotating around the central object, which is going to become our sun. And you'll learn about how, the planets gravitationally attracted more and more material, how they swept out any gas that was around them. And so the planets were formed. If it happened here, it should happen elsewhere. And it has. Right now, I just checked yesterday, there are, 5,250 confirmed extrasolar planets. That means planets orbiting other stars. And some of those are in the habitable zone. That means the conditions at that distance from the star is just right that liquid water can exist. And liquid water is absolutely essential for life at least life as we know it. And so we found even a number of close approximations to Earth. And you can read about that in the extras for this module. One of the other extras for this module, I will tell you, is a video about one of the moon landings. In fact, one of the last moon landings, Apollo 16. That was really one of the earlier scientific missions. 16 and 17 really did a lot of serious science there. And they took a moon buggy with them, a little car that they unloaded from the lunar lander and used it to drive around the moon. It's a really great video. It's old. It was made around the time that the landing took place. And that means it has sort of an old flavor, but it is the single best video I've ever seen that really shows what goes on during a moon landing, both on the moon and on Earth. So please watch that. I think you'll enjoy it. But gosh, so many planets that we know of, 5,250 other extrasolar planets. And is one of those inhabited? That we don't know yet. And I can't wait to find out. Now, before we go, I want to take a look at Stellarium. And so let me pull it up here. So let's see what's in the night sky. We've been talking about where did our solar system come from. We've also talked about exoplanets. And it's important to know that there's a place you can look in the sky right now and take a look at the location where there are planetary systems being formed today. And that is in the Orion Nebula. This is what the sky will look like. I've set it up for the 14th. That is Tuesday. That happens to be the night of the third quarter moon. But the third quarter moon rises late, so it's going to be a fairly dark sky for you. And you can look south. This is around 8 o'clock. You can look later. Orion will still be up there, but let's look up a little bit. And here is the constellation of Orion. Betelgeuse, the red giant star, up there on the upper shoulder. Rigel, the white hot giant down at the lower, on the lower knee. Here are 3 stars in Orion's belt, and just below the belt is the Orion Nebula. And so this is about 1,300 light years away, I think 1,360 if I remember right. But that means we're seeing the Orion Nebula as it was about 1,360 years ago. That's when the light left us. And so we are looking into the past a bit. I'm zooming in here to show you what it is you can see. Now, you would need a telescope to get a good view like this, but just with binoculars, you could see the nebulosity, the glowing gas there is around this nebula. And in here, there are some very bright newborn stars. And, and we can even see the disks that are forming around those newborn stars that will one day become stellar systems of their own. And who knows, somebody way far out there sometime might have turned their telescopes our way. And maybe they have pictures of our own solar system as it was forming. So please take advantage. This is a great time of year to see Orion. It's high in the sky. So just look south and it'll be right there hovering above you. It's always a great sight. So I hope you'll enjoy learning about the moon, and I hope you'll enjoy taking a survey of our solar system. It's a fascinating story, And in the next modules, we'll take a closer look at the inner terrestrial planets and then the outer planets and other members of our solar system. So everybody, take care. Let me know if you have any questions at all. If you do, you can always send me an email or just happy to set up a Zoom meeting with you, or we can meet in my office. Just let me know how I can help you out. So until then, everybody have a good week, and I look forward to seeing you next time. Bye-bye.